Hey, Morgan.
Hey, how you doing?
Good. And hey, everybody. Welcome to the Weekly Space Hangout for Friday, February 27th, 2015. If it sounds very echoey here in this room that I'm in, that's because this room, which is my girlfriend's house in Louisiana, is completely empty. Check this out.
Oh man,
So,
yeah.
yeah, so we're going to be moving to Canada. So, and that happens tomorrow. So I'm a little distracted, a little busy. If movers walk through, that's what's going on. But the weekly space hangout never stops.
That's right.
Fortunately, that's because we've got Morgan Rehnberg here on the show with me, and he is a one-man news machine. So, hey, what is happening, Morgan?
Well, I just installed about 20 minutes of Windows updates in 5 minutes, so I'm as frazzled as you are at the moment. It's going to be an exciting show.
Yeah, this is going to be a weird one. I will warn everybody. And Sandy Spring was going to try and join us, but then she had some kind of makeup class that she had to deal with. So, and in the planetary geology sense, not the makeup sense. So this week we got a pile of stories though. We're going to talk about SpaceX updates, of course, this week in Musk. We're going to be talking about the Russian Space Agency, a very large black hole, Google Lunar XPrize, superstorms on Saturn, new images of Ceres, and updates on Mars 1. But before we do that, let's take a second and have a sad note here, which I'm assuming everybody here at this point has heard that Leonard Nimoy's passed away. You'd heard that, right?
I have heard that, yeah. I was never a big watcher of the original Star Trek, but you couldn't dodge Leonard Nimoy in the space culture, and rightfully so. He contributed a lot, not just on screen, but also after Star Trek ended, in pushing forward with getting space out there in the public consciousness, and he's certainly going to be missed.
Yeah, yeah, no, this is really. Unlike you, I was a gigantic fan of Star Trek right from, well, I guess like I was like 5 years old, started watching the show, and my parents were big enthusiasts of Star Trek, and so I had a toy phaser that I used to zap really loudly, and it went missing every couple of months, and then I would find it in these weird closets and stuff, which I don't recall ever putting it there. It was really great. And and in fact, my girlfriend was an enormous fan, and she was quite sad. She was crying when she heard the news. So this is really sad, and I guess it has to happen. We've already lost a couple of the cast, so thanks to Leonard Nimoy for all the entertainment and to everyone behind Star Trek. So I guess this is appropriate. I know Alan Boyle will be doing this as well because he always starts all of his his entrances to the Weekly Space Hangout with giving the Vulcan
And
lives
I
on
never learned to do that.
Really?
Really, yeah. I'm not even gonna try. Gotta be one of those people who
Oh,
has to like tape their fingers together in order to make it work.
oh no! Can you wink?
I can wink. Both
Okay.
sides even, so I'm not totally worthless.
All right, well that's awesome. So just to remind you that this is a interactive program, and so you can post some questions. Go ahead and do that in the Q&A app, which is just over on. Well, if you're watching the video, you can click that we're engaging with the audience, and then you'll see a place where you can post your questions. And go ahead, post any questions that you have for Morgan, and myself, and we will try to answer them if we
Should
can.
have plenty of time for them today.
Yes. So I'm going to say hi to David Josie Wesley, Nancy Graziano, Guido Bibra, Elid Avron, Helga Bjorkog, Richard Clark, Sev Dustbunny, Chris Marshall, Giselle Savarine, Tony Lynch, Michael Jobin, and that's it so far. One other thing, just to let people know, so I am going to be in transit next week, and so I'm going to try and pull a David Dickinson and try to find some internet. If everything goes well, I'll be in fairly close to home territory by next Friday. But if not, there may be a delay, or we may have to cancel the Space Hangout next week, which is too bad because we've got a special guest in theory. So I don't want to lose that opportunity. So. Okay, great. Well, let's get cracking. So let's talk about this week in Musk. What's happening this week in Musk?
Yeah, so you might remember a couple of weeks ago, SpaceX was launching the Discover satellite for NASA. This is a satellite that was going to go up to the L1 Lagrange point and observe the sun to chart space weather. But after launching the satellite, SpaceX was hoping to attempt a second landing of the Falcon 9 on their sort of seagoing barge. But that had to be scrapped because the seas were just too high and the barge wasn't fully operational. It was missing one of its engines, and so it wasn't going to be able to hold still well enough in these seas that were several stories high in order to try to land the spacecraft. Now, they're going to need a lot of tries basically to sort this problem out. And they want to make sure that they get all of the possibilities. And so they announced this week that they're upgrading the barge to basically be powerful enough to keep its position in any kind of weather. So they no longer have to scratch landing attempts because of rough seas. And this will hopefully help accelerate the plan of landing one of these guys on a barge and then trying to start landing them on the ground. And before, it would have been the case that maybe every third launch would have been scrubbed in terms of a landing attempt because of heavy seas, and now that won't necessarily have to happen.
Right, but I mean, this is one of those situations where the whole process of trying to learn how to land these rockets onto barges is really just to demonstrate that they can land these rockets with pinpoint accuracy. Once they've dialed this in, they'll be able to land in the nice, safe, stable ground around the Cape Canaveral launch facility. So the irony is quite palpable on this.
Yeah, that's the hope. Another interesting piece of information that came out as they were talking about this is how much of an effect the launch trajectory has on the ease of landing. And so they said they had a much steeper launch angle for this Discover satellite because they were trying to push it basically out of Earth orbit rather than the cargo deliveries to the space station, which you can imagine are in a shallower launch angle so that they can basically catch up to the space station. And because of that, had they attempted to land the Falcon 9 that launched the Discover, it would have been coming back down towards Earth at a much higher velocity, and the pressure on the structure of the rocket would have been twice as high. And so it's going to take some trial and error with these different launch types as well to figure out, well, is it possible in all configurations to land it, and how much mechanism, how much fuel, etc. do they need in all of these various configurations? And I think that sort of subtlety was probably obvious to people who are familiar with rocketry, but maybe wasn't the sort of thing that we were thinking about when we sort of lay out this nice linear track of, hey, they're going to do this, then this, then this, and then bam, magic cheap rockets. Probably there's a few more thises between the first and the last step.
And what's great about this is that, in theory, all of these rockets are going to land, whether they land successfully or unsuccessfully, there's no risk to human life. They're going to be splashing into the ocean, burning up in the atmosphere, crashing onto the deck of the barge, and each one is a learning lesson, and nobody's lives are put at stake.
No risk to human life and no risk to the payloads, because all of these things happen after the successful delivery of the cargo or the satellite or the spacecraft. And SpaceX is clearly prioritizing that, as they should. So this is all extra, basically bonus science, bonus development that's going on.
Yeah. So this is great. Do you have anything else in Musk?
I think that might be about it. I wonder if he's finished writing his book that he started last week yet.
He started a new book? I've been so disconnected from the news.
I think we reported last week that he just had gotten a $3.5 million contract to write a book about going to the moon and Mars or something like that.
Right. Of course, yeah. Okay. As reported here. I should be paying attention to my own show, but I don't. Okay, well, let's talk about the fact that the Russian Space Agency has endorsed the International Space Station until 2024, and that actually has a lot more of a negative connotation than it sounds like. It sounds like they're cheering on the space
it's not as cut and dry, I think, as maybe we expected. And so the space station was first launched back in 1998, and it was given a provisional lifetime. And every time that lifetime basically is approaching its end, all the countries that are working on the space station, namely the US and Russia, have to decide, are they going to extend it for another period of years? Or are they just going to basically evacuate it and allow it eventually to burn up in the Earth's atmosphere. Right now, the space station is agreed upon until 2020. So that means we have 5 more years of agreed operation for running the space station jointly between the United States and Russia. And the Obama administration had proposed extending that through 2024 with the possibility of then extending it to 2028, which would have been 30 years of operation. Now, this was expected initially to be basically really simple, glide right through the Russian Space Agency, but the mounting tensions between Russia and the United States and other Western countries made this a bit more of a political challenge within Russia. And so what they sort of settled on as a compromise is they agreed to this extension through 2024. But they said that after that, they don't plan to extend to 2028 and beyond. Instead, they're going to detach the Russian modules from the space station and basically set up their own space station to do science, research, etc., starting in 2025. And so we got another 4 years out of agreement with the stipulation that, at least as things stand right now, that's going to be it, and things are going to fracture after that.
And right now, I mean, all of the International Space Station crew have Russians on board. So it's usually like 2 Americans, 1 Russian, 2 Russians, 1 American, 5 Americans, you know, etc. And so this is going to fracture too, I guess, that, you know, the Americans aren't going to be training at Star City. They're not going to be learning to speak Russian. They're not going to be launching on Soyuz. You can just imagine all of the repercussions if this kind of a decision actually gets made.
Right. I think it's important to remember that we're talking about, you know, 10 years from now. The situation could be very different at that point. We now have an agreement to fund through 2024. There's nothing to say that in 2022, 2023, Russia wouldn't change their mind and decide that it was a better idea to extend the space station in cooperation with the rest of the nations operating it.
And I could point to you to 24 articles we've written on Universe Today over the last 15 years about the things in the future Russia claimed it was going to be doing in space. That they were going to be building their own space station, they were going to be sending missions to Mars, missions to asteroids, missions to the moon, and none of these things have really panned out because space is hard and expensive, and they're, you know, you could argue that they're the most equipped nation in the world to do this kind of thing, even more than the United States right now, because they have the capability really to launch humans into space, and yet they are still having a really hard time doing it. So, you know, if they do leave the ISS, I think that's really sad, because this space station really was designed from the get-go to support, you know, all of these multiple nations, and it really depends. You know, if you don't have that Russian platform, you don't have the Russian connections. Even like just what just happened this week, right? Like we had this situation a couple, you know, like about a month ago, where you had the astronauts that were on board. There was a potential danger. They evacuated from the American portion to the Russian portion. You're not going to have that kind of safety net. So I think it's a bad decision, but.
Yeah, well, you know, the status quo is a powerful force, and the closer and closer you get to having to make a change, the harder and harder it is to actually decide to make that change. And while Russia is very well positioned right now to be a leader in the space station with the Soyuz capsule and their training facilities, etc., if they want to separate out their portion of the space station to its own facility, they're going to have to develop, you know, the equipment to disconnect it from the ISS. They're going to have to put some sort of engine on it to push it away from the ISS. There's going to be a lot of sort of original development that needs to be done in order to make this happen. It's not like they can just flip the switch and allow suddenly their space station to be separate. And it's that kind of work that, if it doesn't get started soon, is going to push back whatever date this happens to be until a much later time.
Yeah, so we'll see this unfolding in slow motion.
Yeah, overall, this is good news. We've extended it in agreement through 2024, even through sort of one of the most difficult political periods between Russia and the United States in decades. And I think that bodes well overall for the future. We have 9 years now to sort out exactly what might happen when 2024 comes around.
All right, let's talk about black holes of unusual masses.
Yeah, I'm going to put on my Brian Coberline hat here for a moment. So this is a story about a very, very large black hole. It's found at the center of a quasar, which is a sort of a galaxy that has a very active central region, and this is a black hole that is about 12 billion times the mass of our sun, and that's really, really big. But what's more interesting, I think, in this story than how big the black hole is how old it is. This was found at a redshift of z equals 6.3. Now, if you're a cosmologist, you magically know what that is, and you sort of build your daily schedules written in terms of z. I had to go Googling around looking for some sort of converter between z
Wolfram
and
Alpha will do it.
normal people time. But what we're talking about here is a galaxy that's like 13 billion years old. And what that means is we have one of these truly enormous black holes really, really early on in the universe, and according to sort of our basic models of how black holes form today, there shouldn't have been enough time for a black hole like this to form. And it's pretty sort of easy to see why that is. You can imagine as material falls into a black hole, it kind of bunches up around the event horizon. And then friction starts happening. It hits into other material, and it heats up, and it rubs against other material, and it heats up. And what this heat does is it starts glowing. And we know from studying the sun that light actually emits a pressure. And so what that pressure does is it actually starts pushing material away from the black hole. And so you sort of reach this magic limit where so much material has fallen towards the black hole that it's heated up so hot that it pushes away any more material from falling in. And you kind of settle into this equilibrium point that sets the maximum amount that a black hole can grow in any given year. And that changes, of course, due to the size of the black hole. A bigger black hole has a larger event horizon, has more surface area, more material can fall in. But even in sort of the most optimistic cases, there's just not enough time in the lifetime of the universe between the Big Bang and when this black hole seems to be the size that we observe it today for it to have grown to this size. And so it's challenging our understanding of how black holes form. And I'm not strictly qualified to really delve into the details of how that is, but this is a very puzzling object, and it's exciting that we found something that's so old and yet so big.
Well, and this, I think, goes into a bunch of things, right? One of the big mysteries in modern cosmology is, now that astronomers have found these supermassive black holes at the heart of every galaxy, they don't know whether it's the black holes that really form first and then form an anchor that then the galaxy forms around it, or whether if you get a collection of gas and dust and stars of a certain size, you inevitably get this supermassive black hole. And the part that makes it even more complicated is what role the dark matter in the galaxy serves, because the galaxies are really forming at the heart of concentrations of dark matter in the universe. And so when did this stuff all get put together and so on, right?
Yeah, but we know that galaxies started to form around the same period of time. As Brian was telling us last week, the question of what exactly is a galaxy, were the stars starting to form yet at this time, or was it just gas and dust sort of clumping up? This really kind of throws a wrench into this chicken and egg question that you're asking, is which one comes first? Well, now we seem to think that they're both really, really old, and they're both really big at this time. So how could this be?
Mm-hmm. And as we saw within the last couple of weeks, that it now appears that the first stars formed later than astronomers had really anticipated. So again, you did a great job not being an astrophysicist. I thought that was great. So we'll just have to see. But now you're saying that the galaxy is 13 billion years old, but are we seeing the galaxy as it was, when you say was it Z equals, what was the distance?
It was 6.3 was the redshift of the galaxy.
Right.
So yes,
right.
We were seeing the galaxy as it looked 13 billion years ago.
13 billion years ago.
Yeah. So whether or not that galaxy exists still today is something we can't know. We'll have to wait 13 billion more years to find that out. But we were seeing it
and watch it grow up. Yeah.
That's right. So if you're around in 13 billion years, this is probably a good guy to check out.
Yeah. Yeah. Hey, future civilizations watching us 13 billion years in the future, post a comment and tell us what happened. That's awesome. Okay, well, you know what? I want to talk about this white spot on Ceres, because this is just amazing. And I was expecting, I don't know about you, but I was expecting this to be resolved, but it's even weirder.
Right. I was expecting this to be resolved too. So as the Dawn spacecraft has been approaching Ceres over the last couple of months, we've been tracking this white spot on the surface of Ceres. And every time we take a better picture of Ceres, we get closer, higher resolution, the white spot persists. And finally, we got close enough that we thought, well, we ought to be able to see the white spot now in some amount of detail. And we do, but instead of seeing what it is, instead of one white spot, we now have two much smaller white spots. And they're extremely bright. They look like they're sort of in the bottom or on the side of a large impact crater on the surface of Ceres. And one of the leaders of the Dawn mission had a long blog post on the Planetary Society's website this week in which they basically said, we have no idea what this is. And this is really exciting, and we're going to have to wait and find out. And they didn't want to advance any hypotheses at the time. Ice is one popular hypothesis. Recently, I've seen at least one person suggest that perhaps we're seeing some sort of volcanism on the surface of Ceres. Now, this would probably have to be sort of some sort of cryovolcanism similar to what we see on Enceladus, because after 4.5 billion years, it's difficult to imagine how there could be enough heat inside of Ceres to generate sort of lava volcanism as we think of it here on Earth. But over the next, so Dawn will be getting into Ceres orbit in just the next week or two, but it's going to stay pretty far away as it sort of spirals in. And so we're looking at probably another month or two before we really get a close-up picture of this crater, and we really find out what these two dots are.
Yeah, so it's the two dots, those two dots in the middle. Like I'm sharing the picture now, Morgan.
I see it, yes.
Yeah, and so there's that one, like it looks like a laser is being fired off, or like obviously it's not a laser, but
yeah, it's extremely bright.
Extremely bright. Now we don't know how much, like the scientists have had to overexpose the region to try and kind of make this image show up. So
right.
It's still going to be a while before we get really nice close-up pictures. But you're saying that there's like a second dot right beside it, to the right of it, right?
Right. So you can see a dot sort of right in the middle of that crater, and then right to the right of it, in the image, there seems to be a second dot. And so before, when we were further away, those two dots blended together into a big white blob. And that's what we saw, and that's what was leading some people to suggest that this was, ice, for example. But this is much more curious, because here we have that white spot right smack in the middle of the crater. And one could maybe come up with some explanations about what that is. But then we also have that secondary white dot to the right of that. And it seems like it's more on the sloping wall of the crater. And it's interesting that it has that morphology. And I think that is going to challenge some of people's initial ideas about what we might be seeing.
It's amazing. And when I think about, I don't know if you've heard about this recent news that a dinosaur skull has been found on the surface of Mars.
How do we miss that?
I know, how do we miss that? It really looks like a dinosaur skull, so it must be a dinosaur skull. Obviously it's a rock, and it just happens to look like a rock, like a dinosaur skull. But you have these kinds of things where people this is a genuine mystery. We don't know what this is. It's super interesting. I can't wait to find out what this is going to be. I'm not making any, I'm not going to make any wild assumptions for what this is, and we're just going to see this play out. And this is the kind of thing that shows why science is so exciting, and why actual discovery is just so intriguing. I can't wait to see.
It's really exciting to think that we have this big mystery and we haven't even gotten to Ceres yet. This is the cruise phase in which Dawn is traveling from Vesta to Ceres. This is the part of the mission in which usually you expect nothing to happen. It's the same part of the mission that New Horizons is in right now, and it's taking pictures of Pluto and its moons, and we're not seeing anything that we didn't already know. And that would have been the expectation here for Ceres too. But all the way out here, tens of thousands of kilometers from Ceres, already we're confronted with this very puzzling mystery. And I think it really bodes well for a very productive year at Ceres for Dawn.
Yeah, absolutely. This is going to be great. All right, let's move on. What do we got next? Let's talk about Mars 1. Let's talk about how they've lost their TV contract.
Right. So this is not the big TV idea that they had of televising the whole mission and the time the astronauts spent on Mars, etc. This was a preliminary TV contract that they had signed, I think last year, but it might have been 2013, with a television production company to televise the announcement of the selection of the crew. And so they had what they've been claiming as 200,000 applications. Some people have said that's 200,000 people who started the application, but somehow they've narrowed that down now to a few hundred, or maybe it's 1,000.
No, it's 100 people now. Is the latest cut?
So they're at 100 now,
Yeah,
and so the next cut then is to cut down to the final crew, which I think is 8.
Well, the first one I think is 4. But
you can tell exactly how much I've been paying attention to
yeah.
Mars One here. They're going to cut the crew down to a much smaller number, and they were going to have a big dramatic.
You didn't make the cut, did you, Morgan? You sound.
Man.
Yeah.
One day.
One day.
I'll wait for my actual trip to Mars. Not
one day you can
fantasy
die
trip
on Mars. Yeah.
And so they were going to have this big TV event to unveil the final 4 or 8 or however many people it was, and the company that they contracted with, who basically bought the rights to televise this, canceled that contract, and this doesn't bode very well because I mean, this is something that actually could have happened. They certainly could have cut down, and they claim they still will plan to cut down this crew of 100 down to the final amount, but if even that hasn't got the attention of broadcasters at this point, it suggests that they're kind of losing control of the situation. They're losing control of their own PR and of their own timeline, and that's unfortunate for them.
Well, I don't. In this modern age, I mean, here we are doing a television show from my apartment and yours, and obviously, I've got the lighting to show for it. Although your lighting is terrific. I gotta find out. I'm gonna buy your lights because I really like them. But this is the internet. We don't need old news media. And in fact, if you perhaps have a search for the word Mars in Google News and you're looking for sort of every mention of the word Mars, which I do. You're seeing local news agencies all around the world report that a person has been chosen in their local market for this Mars mission. Someone from Vancouver, and someone from North Carolina, and someone from Abu Dhabi and Australia, I think their public relations. They're on point. They're doing a fantastic job of getting the public relations out. And if they don't get to be on television, air quotes here, who cares? We've got the internet. They can publicize themselves on the internet as well as they want to, and so I don't think it's really that big of a deal.
Well, and that would be 100% true if being out in the media was just a publicity operation. But this is their entire business model. They're looking to raise billions of dollars to go to Mars, and they're doing it by saying that we're going to broadcast a reality show on television that millions of people will pay to watch. And the fact that they can't even nail down a small television contract that only a few people might choose to watch doesn't suggest that they're really in a situation where they can nail the big one that they need to actually get off the ground. And so, yes, people are talking about them. We're talking about them. You can go to Universe Today or Space.com or CNET and read articles about them. But none of that's paying them any money. And ultimately, that's what they've predicated their whole mission design on. And that's got to be frustrating for them to see that they're getting all of this publicity, but not in a way that is generating revenue that they need to actually proceed then with the rest of the mission.
Right. So I got a question here. I don't know. Are we done talking about Mars One?
Sure.
I was going to move on. I don't know if you had anything else to say.
I don't have anything else to say.
Okay. All right. So this question comes from Jason Carlson, and this is sort of about the series. Emily Lakdawala's blog on Planetary Society mentioned that the bright spot was about 40% reflectivity. What material would fit that mold? I mean, isn't Enceladus have an albedo of 99%?
Right, and
So
so I think this is
ice.
exactly what you were alluding to with saying we don't know how much the scientists have stretched and manipulated this image. Asteroids are extremely dark. They reflect, 5 to 10, maybe percent of the light that bounces off of them. So in order to make it so that we could see the nice outline of Ceres with its craters and all of that, they really had to crank up the brightness, crank up the contrast. And that is going to, in fact, serve to blow out what would otherwise be, a moderately bright object. And so if Emily says that that would correspond with a 40% reflectivity, then I think that is encouraging because, you can imagine a lot of combinations of things that can reflect 40% light. It's probably some combination of ice and dust and dirt, basically, from the asteroid. And so nothing in space is pure, basically. And so even if you went on Wikipedia and found a material that reflected 40% light, the odds of that being what's on the surface of Ceres are very slim. In reality, it's probably a complicated combination, both chemically and then sort of physically how it's layered on the surface. There be ice intermixed with dust, with dirt laying on top, and it all sort of adds up to the reflectivity that they're seeing. So
Right.
really, I don't think, until we get close enough to make some sort of spectroscopic measurement where we can start to identify the components of that, or close enough that we can resolve it and start to see the shape and the morphology of it, we're not in a place where we can really answer the question of what that material might be, even if we admit that it has a 40% reflectivity.
Right, and we did a post on Universe Today a few weeks back where we compared the albedo of the Earth, the Moon, and 67P, and Enceladus, with Enceladus being 100%, the Moon, I forget what it is, like fairly low. Earth is actually a lot brighter than the Moon is, but 67P is like just almost indistinguishable from the background of space. It is an incredibly dark.
Yeah, I've heard it described as dark as coal.
Dark as coal. Yeah, it is an incredibly dark sort of object. So for it to be 40%, that's actually quite bright. And I mean, I guess Ceres itself has a fairly low albedo, and then but the fact that the albedo is so different from the rest of the object, this is what makes it really fascinating, right?
Well, yeah, and the fact that it's such a local phenomenon. We're not even sure how small it is yet because we haven't been able to resolve the actual thing that's doing the reflecting. But every time we take a better picture, we shrink the maximum size that object or feature, whatever it is, could be. And now it's shrunk down to be much, much smaller than the size of that crater. And so the fact that it clearly is a very distinct, a very isolated feature, I think, is part of why people are excited about it, because that suggests that maybe there is some sort of very local phenomenon that's going on.
Chris Marshall asks the question, could the ISS operate without the Russian side of the station? Will they need to launch additional modules if Russia does leave?
I believe that it can operate without the Russian side. I think that pretty much every major system is duplicated between the United States and the Russian sides, but when this split occurs, if it does occur, both sides will be giving up that redundancy. And there have been times in which instruments or systems from one side or the other have failed, and they've been able to switch over to the other side, and that's what has allowed us to have 17 years of inhabitation of the ISS now. We'll be giving that up if we separate the spacecraft or separate the space station and don't send up additional modules.
Yeah. So and this is exactly right. So they can independently operate, but the as we saw, the Americans had to evacuate to the Russian side of the station. If they couldn't do that, they would have to evacuate to the Dragon capsule or some additional other part of the station, and perhaps even evacuate the station entirely, even if it turned out to be not a problem.
Yeah, I think if this were to happen, and again, it's unlikely, I think, to actually occur, but if it were to happen, I think this would be a tremendous opportunity for some of the smaller space nations like India or Brazil or Japan, to launch additional modules and sort of rebuild the International Space Station in the next generation form with a new coalition of leading nations. The ISS has been dominated by the United States and Russia, and if Russia chooses to leave, there's an opportunity there for other nations that in the interim 10 years will have greatly developed their space programs to start a new collaboration. And so I think it doesn't, even if this happens, it doesn't have to be doom and gloom for the future of the ISS or the future of cooperation in space.
Yeah, I mean, India for sure, who has been making a lot of news, and they're upgrading the size of their launch vehicles. And, China. I mean, I think this might be a good opportunity to sort of build some bridges between the U.S. and China as their relations to space, because I think a lot of what's going to happen in the future of space exploration is really going to come down to what China does. That's the new space race. So it'd be great to have them be partners as opposed to be competitors.
Absolutely.
And a similar question, this comes from John Davis. How many of the modules are Russian? Will the station be viable after this? So we talked about the viability. I'm trying to remember the exact number.
Yeah, I don't remember the breakdown, but I imagine
5.
that it's at the top of the Wikipedia page. So
yeah, there's about 5, I think. So there's the Zvezda, the Zarya, there's the Pirs docking module, and there's, I think, a couple of others. So there's not a lot.
Yeah. Well, and we should emphasize, I don't want to belittle or play down the contributions of countries other than the United States and Russia already. I believe Japan has a laboratory module, as does ESA from the European Union. And so if Russia chooses to leave, it's not like it would solely be an American space station at that point. There have been other nations that contributed, and presumably they would choose to continue to keep their modules attached to whatever remained of the ISS.
Tom Nathy notes that the visual albedo of Ceres is about 7%, and in comparison, the Moon is about 12%. So Ceres on its own is dimmer than the Moon, if you just could compare reflectivity to reflectivity. So that just makes this pinpoint bright spot so much more interesting.
Absolutely.
Okay, great. Let's keep rolling. What do we got next? You had one more about the Google. Oh, you got a couple more. All right, so let's talk about the Google Lunar XPrize. See, this was in This Week in Musk.
Yeah, it kind of straddles into that realm. And so, yeah, for the last few years, a number of private entities and universities have been competing to develop a moon rover, in essence. And Google, through the XPrize Foundation, has offered $20 million to the first organization, the first team, that can land a rover, or optimistically they say a hopper or a digger or anything, and travel 500 meters on the surface of the moon and return HD video back to the Earth in, I believe, real time or near real time. And if you do that, you can claim a large chunk of that $20 million. I think it might be $12 million for the first prize. And so a number of teams are competing to do this, and originally it was supposed to be done, I think, at the end of 2014, and that deadline's now been extended through the end of 2016. But in order to do this, you have to get to the moon. And that's certainly the most expensive part of this entire project, if not the most difficult. And so two companies, or two teams, have teamed up to share a Falcon 9 ride to the moon in, I think, mid to late 2016. And I think it's worth emphasizing here that nobody's making money off of this competition, because a Falcon 9 costs something like $70 million to launch. So if you split that in half, and you get $35 million footed by each team. If you win, you get $12 million. You're still pretty far in the hole. And so it's good to have this sort of cooperation, because it raises the possibility that any team will successfully reach the point of getting to the lunar surface. And if that happens, then that'll be a big step forward for our exploration of space, because it'll show that it's now open to not just major nations, but also independent groups that have the backing necessary to build the rover and then purchase purchase the trip to space, which hopefully with the increasing efficiency of the Falcon 9 will become cheaper and cheaper.
I think that's pretty funny though when you think about it, because if the two are going to share the launch, then it's really going to be a photo finish to who can.
Yeah, they're describing it as a NASCAR race on the moon, and they've developed some sort of system to ensure one company's actually sending out 2 rovers and the other sending 1, and they've developed some sort of system to ensure that all 3 basically get to start at the same time when they get to the moon, because you can imagine it won't take much of a head start to give one team the win.
Yeah, and then really it's whose rover can cover the distance that is required by the XPrize to actually take home the final prize. I think
imagine if that was a televised event.
Right.
You know, that would get my attention.
That's awesome.
Sure.
I think we will. If no one does, we'll cover it. We'll cover live coverage of it. Now, I need to provide an appropriate disclaimer, of course, which is that I work for HeroX, which is an offshoot of the XPrize. So I sort of work for them through a sort of series of connections, but I'm in no way involved in this process. So. And then, of course, Dr. Pamela Gay, my co-host on Astronomy Cast, was hosting a weekly show about the Google Lunar XPrize, so helping to sort of explain more about it. So just to let you know, we're completely biased towards exploring the moon. I didn't know that the Falcon 9 could do a lunar transfer orbit, but I guess if the weight on the rocket is low enough, then it's possible.
Yeah, I didn't know either, but certainly these rovers are a tiny fraction of the sort of hardware that the Americans were using the Saturn V to launch. And it's worth noting that the Soviet Union and China and the United States in the past have all launched and landed small rovers or landers on the surface of the moon. And so you don't need a truly, behemoth rocket to do that.
Cool. Okay, so let's talk about your specialty, Saturn.
Right, so this is research that came out of observations that were made a number of years ago now. Back in 2010 and 2011, there was an enormous storm that was raging on the surface of Saturn, and almost surely you've seen the pictures of this storm. But it was at its maximum about 25 times larger than the size of planet Earth. So we're talking about a really, really big storm. And observations of that storm were made by the Cassini spacecraft during this period, and they've been sort of analyzed over the last few years. And the latest discovery is that this storm basically dredged up water from underneath the surface of the cloud layer basically of Saturn. And they proposed that this water might have even been liquid or gaseous underneath, and then froze as it came up towards the cold outer layers of Saturn, and then became ice crystals to be detected by Cassini. And storms like this are really valuable because they reveal the interior of a planet like Saturn. Now, when we look at Jupiter, Jupiter has all of those big horizontal stripes. It has the great red spot. It's a much more active appearing planet on the outside, and that's helped us know a lot more about the atmospheric composition of Jupiter than we do Saturn. Saturn on the surface appears to be very smooth and tranquil, although in reality the winds there are also moving extremely fast. But because it's pretty uniform, we haven't had a good way of looking down into Saturn to get a sense of even what the top layers look like. And so this huge storm, which would have stretched many, many, many kilometers down into the Saturn atmosphere, revealed some of the hidden components that we probably suspected were underneath, but we had never actually been able to observe directly before.
Cool.
Absolutely.
Yeah, it's great to have these natural, once again, sometimes nature does some of our science for us, and in this case, creates a gigantic scoop that digs into Saturn and flips it over so we can see what's inside.
That's always nice when we're right there to look to.
Yeah, it's, when you think about it, like when we had the comet Shoemaker-Levy 9 that crashed into Jupiter and splashed up parts of the interior of the planet so that we could take a look at what that looked like.
It's amazing how many astronomical discoveries have been completely the result of serendipity. And it makes you wonder how many we've missed just because we weren't looking in the right place at the right time. Even over the last 20 years, we could have missed a whole bunch of things that would have revealed a lot of great new stuff.
Let's see. I'm just see if there's any more questions here that I want to pull. Chris Marshall notes that that adding Bigelow articles could be useful for shoring up the International Space Station, and this is, I think, a great point. Bigelow Aerospace has developed these really cool inflatable modules. They've launched a couple of them, and they're running a bunch of tests. And I know NASA has also done a bunch of tests on these idea of these inflatable modules. It's a great way
I think there's one up there right now that's about to be deployed for testing.
Yeah, there's a great way that you can sort of launch it in a very compact form, and then you raise it up to the station, and then you can inflate it in space, and you've got tons of living room, and it's going to be a really great way. And your air acts as sort of to keep the thing sort of inflated. So I think it's a great way to go. I would love for them to start testing out some of those inflatable modules. And if they test that out, then they'll understand what it's like to work with an inflatable module when they start to think about putting these things on, maybe taking them to asteroids, taking them to the moon, taking them to places like that. I think this is all really, really important. So I'm quite excited.
Yeah, the breakup of the ISS, if it happens, doesn't have to be a doomsday scenario, and I think it does open up a lot of opportunities if companies and countries are willing to commit what is, frankly, a substantial amount of resources to maintaining something like that.
Yeah, yeah. John Davis asks, what are the sizes of the white dots on Ceres? So do we know how big those dots are yet?
Well, I don't know, but I'm sure someone's measured the size of the dots. But it's important to know that the size of the dot is not the same thing as the size of the feature that caused it. The features are unresolved right now, which means basically all of that light is falling into 1 pixel. And then the dots look bigger than 1 pixel because they're so bright that they fill up that 1 pixel on the camera of Dawn, and it kind of overflows into surrounding pixels and basically fills those up as well, and then those can overflow, etc. And so because of that, the true nature of the feature, the true size of that feature, is unknowable, other than the fact that we can say that it's smaller than some given size that would be defined by whatever the size of 1 pixel is on the size of the surface of Ceres right now. And if I recall correctly, we're talking about pixels being on the order of about 5 kilometers on the surface right now. So we know this is a feature that is probably less than 5 kilometers in size, which is quite small considering how visible it is from this distance.
Nancy Graziano notes that William Shatner never mastered the live long and prosper hand gesture. He had to tape his fingers just like you, Morgan. So you're in good company.
I am in good company.
Do this. Aw. Awesome. Okay, cool. Well, thanks, Morgan, for showing up on this this very special episode.
Thanks for having me.
Space Hangout. Where can people find out more about you?
Yeah, well, right after this, if somehow we didn't get enough questions answered, I'll head over to the Google Plus Space community for a bit, take general questions if we want to talk about things we didn't talk about on the show tonight. Also, you can find me on Twitter. I am at Morgan Rehnberg, and you can visit my blog at cosmicchatter.org.
Awesome. And just another reminder as well to check out the Weekly Space Hangout crew, which is a great community on Google Plus that really supports this show. And a lot of the names that I was mentioning are people who are part of the crew, and I know they just crossed the 300 mark in terms of membership, and the membership is very active. So if you're looking to sort of support the show, if you want to talk about some of the stories that we talk about, if you want to even propose ideas for guests for us to have at the show, they're very, we are really connected between what we do here on the show and what is happening with the WSH crew community. So you should absolutely join that community. It's over at Google+. On my side, we've been still putting out a ton of videos. We just crossed the 40,000 YouTube subscriber mark, which is kind of mind-bending. So thanks to everybody who has been subscribing to us on YouTube. If you're watching this and you haven't subscribed, then go ahead and do that. You really should. And then you'll get a chance to see all of the other cool videos that we're doing as part of the Guide to Space. We just put out whether or not the Milky Way will ever become a quasar. And earlier the week, we answered the question on whether or not there could be a mirror Earth hiding on the other side of the sun. So I'm sure you know the answer to that question, Morgan. So you should check it out, though. So cool, and we got a bunch more stuff coming out. So once again, I'm FKN on Twitter. I'm on Google+. Check out Universe Today. Follow us on YouTube and all the other places where we are. So thanks, everyone, for watching, and I hope we will see you all next week.